Okay, so now we're going to let the fun begin. So, first project is we're going to upgrade the Deerc 9201 from a brushed 540 motor to and a brush system to a brushless 3650 3900 kV motor with a 60 amp ESC and a separate a new controller with a separate receiver. We have to get a new receiver and transmitter because in this car the ESC and the transmitter are integrated into the same device, and so we need them to be separate because we can't use the transmitter, also because the old transmitter is bound to this one and we won't be able to use it with the new ESC or the new receiver as well. So, brief description of the components. This is a BL motor, that's the brand, 3650. That's the modeled engine. It's 36 millimeters long, it's 50 millimeters long and 36 millimeters wide. That's why they call it the 3650. And it's 4 poles, which means it has 4 magnets in it. And 3900 kV. In electronics engineering, kV normally means kilovolts, but in the RC hobby it means something totally different. Constant velocity, and K is not used to spell the word constant, but they use a K. I think K means constant in physics, but that's what it stands for, constant velocity. And 3900 means if you apply 1 volt to this motor, in 1 minute you'll have 3900 RPMs. So that's how they gauge the size of the motor and the speed of the motor. And you have choices. I could have got one with a faster kV, I could have got one with a lower kV, and in general the faster the kV, the higher your motor, the faster your motor is, but the lower the kV you generally have more torque. And so in referring to other hobbyists online, this is, you get something in the middle, so I think this is going to work out well. In terms of the ESC, the electronic speed controller, this one is a 60 amp controller. If you can see it, it says here 2S, 3S, and it says LiPo, so it works with the LiPo batteries. So I actually will be able to run this, should be able to run this with 3S if it works as advertised. It has a fan on it as well. So this is the ESC, and I had to purchase a transmitter and receiver combo. This is a popular one, Dumbo RC. Don't ask me where they get these names from, but this is a very popular one. It gets good reviews, and is it's fairly reasonably priced. And I'll talk about the prices later on. I think I'm spending like about $75 to $100 for the upgrades, and I'll get the actual facts for you. So this is the transmitter, and you have to get a new transmitter, and this is the receiver. That being said, we're going to roll the car to the rack. Oh, this is another invaluable tool. This is your vehicle stand, and it's just a 2x4. I think I'll paint it so next time you all see it, it'll look more professional, but it's just a 2x4, and you use it to set your car on. So when you have your screwdrivers and when you're pressing down on it, you get your full amount of pressure. So if I press on this screw, or let's see, if I press on this screw right here, or any screw, the car doesn't move. But if I don't have the stand, you'll see the car moves every time I press on it. So that's not very useful. Also, when you take the wheels off, it holds your control arms as well. So now, getting started. Let's get the best focus on here for you. There we go. So, here's the motor right here. So we start by taking out these screws, and that will free up the area between that secures the motor to the chassis. And you'll see the pinion gear and the spur gear in here. So let's go ahead and do that now. And in doing this, you try to pick or choose the right screwdriver for for the right job, and you get a feel. When you put the screwdriver in, you move it around, and if it grabs real good, that's the screwdriver you want to use. So we're going to go with the number 1 screwdriver. And why I like to use the screwdrivers, if you notice, I take my palm. Let's see, let's go back a little bit. I take my palm and I hold it here and I spin it. And that works really good. Another tool you'll see me use is I use magnets. And I use magnets, oops, I missed, to keep my screws from going all over the place. So, spin. Some people like to get the electric screwdrivers, but for me, it's a little overkill. And when you're just starting out, you want to get what's called the mechanic's feel. The mechanic's feel is knowing when to stop tightening before you damage anything. Whether you strip out the threads in the hole or the threads in the screwdriver. So let's talk about that then. When you say the threads, here's your screw. Let's see, is the camera going to focus on this? I think it will. Your screw has threads. And so these hold the screw head down, and you go over torque it, which means make it too tight, and it'll pull the mating threads inside the hole and damage it to where it doesn't work anymore. So when you tighten these, you got to know just enough. It has to be tight enough so it holds, but not too tight where you damage the threads. And that process is unofficially called the mechanic's feel. And they call it that because a mechanic, because they do this all the time, they know exactly what it should feel like. And you can get that too with practice. And if you notice, this screw is much longer than the other ones. Let's bring this down some. Get to change the angle on that. I think that might be a little better. Okay. So yeah, this is a longer screw, and with this longer screw, you might say, how would I know which one it goes back in? So I have to make myself a mental note, or I have to mark it so that I don't get confused. The rest of the screws are all the same size, so I'm not worried about them. This one's so much longer, I'm saying to myself, it has to go someplace where there's room, and this is the highest point on this back here. So now I'm going to put this here. And we got all these screws out. Is it ready to come out? Looks like it, except something back here is holding it. Let's go back a little bit. There. So now, as you can see, the cover on the motor's coming out. Look at there. Okay, well, I'm going to do this in a way where it's a little more methodical. So what I'm going to do is I see that this has a tie wrap here, zip tie. So I'm going to get my diagonal cutters. I'm going to cut that zip tie and pull it out. And I'm going to take these screws out right here because they're holding this support. This is a chassis support bar as well as a cover for the pinion and spur gear, and we'll get to that in a minute. So now we'll take this out, and once again I can spin it. Hey, I dropped it and it went right on the magnet. What do you know? And I'm going to do it again. Spin it. And these are shorter screws, and what's going to help me remember that these go here is because there's not that much space between the screw and its mount, so I don't have a problem with that. And these are some smaller screws here. You can see them. Let's give it a spin. And it looks like it's one more holding it. Okay. Alright, so the support rod comes out. We set that to the side. And now here's the motor. So the motor is not in its original. Let's get a better view of that for you. Okay. In fact, I'm going to turn the whole car around. There we go. Should get a better view. I think that's a better view. So now, the motor was, this is the motor mounting bracket was actually in here like this. So when you look at it, this is called the pinion gear. It's the same thing this here. It's called the pinion gear, and this is called the spur gear. And when it goes, you see that's how it works. The motor turns the spur gear. The spur gear turns this long shaft, that's called your drive shaft. And this long drive shaft here actually hooks to the differential in the front. So you have a differential in the front, and that's what turns the front wheels. As you can see that going there. And it has a differential in the back that's very close to the motor and the spur gear, so it doesn't have a long shaft, it has a short shaft that goes into here. So now we can take the motor off. And there's the motor. There's the pinion gear. This right here is called a heat sink. This is made out of aluminum. And the purpose of the heat sink, let's see, get the little there. The purpose of the heat sink is to dissipate heat from the housing of the battery of the motor. Motor gets hot. This metal casing dispels heat, connects to the aluminum here, which is a softer metal, and the heat dissipates to all the fins here. So we're going to take that. We might be able to use that from the new motor, hopefully. And now, the motor, as you can see, is free. However, it is still tied to or connected to the electronic speed controller, the ESC. So what we're going to do now is disconnect the connections to the ESC so we can handle the motor freely. So I think I can just pull them out, maybe. Yes, they pull right out. And there's the motor. We're going to put the motor to the side here. Here's the ESC right here. And so now what we're going to do is we're going to remove the ESC. And the way we do that is we probably want to disconnect the wires first. So let's do that. I think I can just use my fingernail to pry these up. Maybe, maybe not. We'll find out. Oh, maybe my fingernail's not hard enough. Let me try it again. Nope, it's not coming. So what I'm going to do is I'm going to take a screwdriver and see if that works. Give it a little pull, but you don't want to pull too hard in the wires because you don't want to pull the wires out. So I'm putting the screwdriver underneath this plastic here and giving it a little tug, and it's not coming. So it may have some kind of mechanical connection. So let me turn it. Take another look at it. No, it doesn't. It should come out. There it goes. Just had to be patient. Had to rock it back and forth. There. So it's out right now. Okay, and is it free? No. This vehicle has headlights. And so they're LED headlights. If I can show them to you. These are the LED headlights right here. And the wires go from the headlights to this connection right here to the ESC / receiver. So I'm going to pull these out and put them in the, may have a place for the new ones. And now it appears that the ESC is now free. So how do we get the ESC out? You don't want to just yank on it. You want to look at it, and I see that it has, some of them have screws in the bottom. This has some screws in the bottom here. Right here and here. That may get it out. And also it has a connection here, but I think that holds the ESC together. So we're going to go to screws. Get my #1 screwdriver and turn it upside down and take these screws out. On my magnet so I don't lose it. And for the other screw. Hey, come on out. Okay. It's sitting there because the ESC is now free. So I need to push it from the bottom and put it right there. So now the motor is out. The ESC slash receiver is out, because remember, this receiver and ESC is all in one. This one, if you look at it, let's see if you can get a good look. This one says 45 amps on it. And yes, 45 amps. So the upgraded one is 60 amps. Here we still have the servo, the steering servo. So we're going to leave. I bought another steering servo, but I believe I'm going to go ahead and keep the one I have, because I don't think anything's wrong with it, and I think it'll serve me well. So, but just in case, I have another steering servo over there that I can use. Alright, so now that we got the components out the car, we're going to take a quick comparison while we have them on the bench, and then we're going to preview the next step. If you notice, the brush motor has 2 wires, and this is how you can tell the difference between a brushless motor and a brush motor. Brush motors have 2 wires, brushless have 3 wires. Okay. The brush motor actually can be hooked directly up to a battery to operate. In fact, I think I got a battery over here. Let's see if we can get it to spin up. This battery, yeah, this battery will work. Got to be careful not to short it, because there's a lot of current in these batteries, and it could be a really nasty spark, and it could possibly catch on fire if I'm not careful. So I'm going to be very careful. And I'm going to hook the battery up here. See if I can get it to spin. I'm going to hold it because it's going to jump. Hey, it came out. Ooh, don't. No, it's not going to short. The way these connections are made, you can't short it on the battery, but you can short it by sticking something in it. Short it means connect the parts that aren't supposed to be connected, and that's not a good thing to do. So you got to be kind of careful with this. I think I can get it. Oh, there we go. Kind of started me a little bit. We got action. So the motor is actually running now. Can't do that with the brushless, because the brushless needs the sophistication of the circuitry in the ESC, electronic speed controller, to send pulses to it, because this is what's called a 3-phase motor. And the pulses are sent in 3 different phases, which causes it to turn into the degree so that you get the rotation. So you can't just hook it to a battery. It has to have an ESC, whereas the brush motor does not have to have an ESC to operate. Next, we're going to take a quick look at the ESCs. The older ESC, once again, has an integrated receiver, or built-in receiver. The built-in receiver, this is the receiver for the new one, but this has an on-off button for the ESC, and it has an antenna for the receiver. And then it has the battery connection, and then the wires that go to the motor. Whereas the ESC for the brushless motor has the connector for the battery, has 3 wires to give power to the motor, and the receiver is separate, and it connects through this wire here to here. That's how the receiver is connected. And the on-off switch for this particular one is on a wire. This one has it built on. This one you have to mount it to the side and turn it on and off that way. And if you notice, it's a lot bigger too. is a lot larger. Reason being is because it's 60 amp instead of 45, it has to dissipate more heat, similar to the motor. And this actually here are copper fins. That's part of a heat sink, just like the aluminum heat sink. This one looks copper, and it has an actual fan on it. I don't know if you can see the fins on the fan, but it has a little fan on the motor, and with the motor, so it'll spin to keep the ESC cool, because more current means more heat. Alright, so with the motors, you may notice that they have different pinion gears. So this pinion gear I bought with this one, and I didn't count the teeth. So I took a guess, and I guessed incorrectly. This pinion gear is not the same as this pinion gear. So I'm going to have to pull this pinion gear off and put it on this one. In fact, to get this mounting plate, this is the mounting plate, to get this off I have to pull the pinion gear anyway. So that's the pinion gear has to come off, and that will probably be the most challenging aspect of this whole upgrade. Some pinion gears, like this one, have a hex key. Sometimes they call it a grub key. They have a hex key that you can hold. The key is in there, you can just screw out. So if I get my hex key wrench tool, I can just turn it to the left and take it right out. This one's good to go. This one, however, is going to take some endeavoring to get this off, because it's pressed on here. And pulling it and holding the motor, pulling it and prying it from the motor is not the best way, because you don't want to, this motor is good, I don't want to damage it. If I didn't care about damage, I'd just whack it off and get it off any way I can. But I want to get it off in a way where it doesn't damage it. And there's several ways to do it. One is to apply heat. The heat will expand the pinion gear, and the little pulling, it'll come off easier. Unfortunately, this darn plate is made out of plastic. So if I put heat on here, if I'm not careful, I can damage my mounting plate, and then I have to order another one. So I'm not exactly sure how I'm going to do it. I think I'm going to try the heat method and try to pry it up. Another way is to, let's see if I can use those pliers. If I put a piece of metal underneath this, a thin piece of metal, I can actually push or hammer the tip of the armature. The rod inside here is called an armature. This is the armature end, and I can actually press on that to press it out, or I can just pull it out, but I don't want to damage the plate. So I am going to pause right now and contemplate on how I'm going to do this, and we shall continue and see. Okay, so we're going to go with try method number 1. What I have here is an inexpensive blowtorch, and just right here, I think that'll work. This blowtorch actually is a cigar lighter, and you can get them at any place where smoke shop or cigarettes and cigars are sold. And you say, what kind of cigar lighter is that? It looks like a blowtorch. Well, it works like a blowtorch. If I turn it on, you can see the flame. And it's propane. So the way it works is, if you pull this off, yes, this is a cigarette lighter. It's a plain old cigarette lighter. And that cigarette lighter works as a fuel cell for this blowtorch. I saw this on one of the Discovery Channel shows where they were mining for gold, and the guy was actually doing soldering with this. You can actually solder with this right here, and I said I got to get one of those because it's just so handy. So it's easy to fuel, easy to use, and very inexpensive. So this goes in like that. This goes on here. You lock it, and now you have a blowtorch. Oops, unlock it. So I'm gonna use this cheapy blowtorch to try to heat this up, and once I heat it up, I'm gonna get my angled pliers and try to pry it like this. That's what I'm going to try to do. Just like that. I'm going to try that. I have to be careful not to hit the plastic because I don't want to have to order another one of those. And if it doesn't work, we'll try method B. So right now we're going to try method 1. So here we go. Also, I know this channel's for young people. Children, young people, you should not be trying this on your own. Do not try this without adult supervision. Better yet, have an adult do it. But have the adult look at the video, contact me. But you got to be careful with this because someone can get seriously hurt. I'm going to rotate it around and try to make sure the whole thing gets heated up. Careful not to hit the plastic. Now I'm going to get this part here too. If I hit this, I'm not going to hit the plastic. Get it nice and warm. Heat expands metal. Got some smoke going on. And this is not going off. There it goes. So let's see if we can get some action going on here. So far, so bad. It's not coming off. Heat up some more. Got a little smoke going on. It's nice and warm. Try it again. May have to do method number 2 because this does not. Look at there. Look at there. You're watching this live. It's not Memorex. Boom. Woo. Let me get it before it melts my surface. There we go. Put your mind to it. You can do it.